Hello again, everybody. Welcome back for week 5. This week we're going to be talking about the Linux file system and utilities that go along with that. A lot of this is going to be kind of recap, some of the same commands and stuff that you're used to using and used before. Some of it will probably be new things, especially file permissions and some of the stuff on symbolic links and that may be new to you. So I'm going to kind of breeze through the lecture here. Make sure you do the reading. It's going to cover a lot more of this in a lot more detail. And as you're going through the reading, I definitely encourage you to kind of go through the examples that he's giving in the book, and have your VirtualBox or your Linux terminal open, and kind of go along with the book and the exercises he's doing there, and play around with those and make sure you're understanding the concepts. So let's jump in. So the Linux file system is basically what you could think of as a tree structure, and it shares a lot in common with other Unixes and their file systems. But there are some slight differences. We're going to mainly talk about Linux here and its file system and its standard. Like I said, it's kind of a tree structure. Everything grows off of the single root directory, and in paths and in the file system, the root directory is represented by a single slash character, and then that slash character also indicates structure in a path name. So slash user slash local slash bin indicates the leading slash is the root directory, and then there's a user subdirectory, and then a local, and then a bin subdirectory under that. I believe we went over this before, but this is a kind of a common quote for Unix and Linux. On a Unix system, everything is a file, and if something's not a file, it's a process. So that's the basic metaphor on the file system, is that everything is a file, including directories. They're just a special kind of file. A directory is a file that stores pointers to other files. And then Linux and Unix file systems are case sensitive, and that's something you need to remember, so that a file that named foo with a capital F is not the same as a file named foo with a lowercase f. So you can have several different files in a directory with the same name with different capitalization, and they'll all be different files. So here's kind of a simplified representation of the structure of the Linux file system. It's a tree file system, but usually the tree is represented upside down, so that the root directory is at the top, and then everything branches off below that. So you can see, the main directories at the top of the tree, just under the root directory, are bin, where the essential system commands are, the dev directory, where all your devices live, home, where all of the user home directories go, etc, which is where all of the like system configuration files will live, and then var for variable information, variable files. That's where the system logs go under there, under var log. The lib directory is the system libraries, and then there's user, which on Unix and Linux is USR, because they like to keep everything short. So user, and under user there's another hierarchy, a structure there. So there's like user bin, which is where non-essential or user commands will go, and then a user local directory, and under user local there'll be another whole structure of user local bin, user local etc, user local var, all of those, and those are, as it says, local. Those are all files local, just for that server. So they're not standard to the OS installation, but they're added locally. So there could be utilities that you add or scripts that you write, that you use in your organization or for automation, or that would go under user local. I've left some of them off. Like there's also, you see bin. There's also sbin, which is where the super user utilities go. Those are the commands that are meant to be run by the root user. Every file on the file system has a path. And the full path is directions to the specific file or directory, and like we saw before, they usually start with the slash for the root directory and then just list the path all the way down to the end, separated by the slashes. So an absolute path tells you, from the root directory all the way down through the file system to the end, to the actual file you're looking for. So that tells you exactly where it is, starting from the top of the file system. Then there are also relative paths, and relative paths lists the files relative to the current directory, the working directory that you're in. So if you're in your home directory and you have a directory under that called desktop, and then a file under that named it_group.jpg, so that's a relative path. It's relative to your home directory where you are right now. And you can also go up and around to different directories. So if you were, say, in the desktop directory and under your home directory, and then also under your home directory you have a subdirectory named code. So 2 dots indicates the parent directory of where you are. So 2 dots to go back up, and then to code, and then an info.php file. And then the current directory you're in is called the working directory. That's the directory your shell is currently associated with. That's where you're working right now. So if you look at a file with no path at all, if you're trying to find a file, or you're editing a file there, and you give it a file name with no path, it's going to look or create the file in your working directory. And use the pwd command to display which directory you're in, and pwd is print working directory. So when you first log into your Linux or Unix system, your first working directory where you start out is your home directory. Every user has a home directory, and different OSs put them in different places. Everyone has a standard. Linux typically puts them under /home, and then other Unixes have different standards for that. For example, OS X puts all the user directories under /users. Solaris puts all the user directories under /export/home. And when you're navigating around the file system, the home directories are represented by the tilde character. So to get to your home directory, or to refer to your home directory, it's just the single tilde character, and then you can put a slash and then anything under your home directory. Other users' home directories can be referenced with the tilde character, no slash, and then their username. So tilde Bob would be Bob's home directory. And when you're using that character, that character represents the full path from the root of the file system. So /home/Bob would be tilde Bob. And so that actually represents an absolute path on the file system. Changing the working directory that you're in is accomplished with the cd command, cd meaning change directory. If you use the cd command with no arguments, it'll take you back to your home directory, your initial working directory, the directory you own. And it works with absolute or relative path arguments, so you could do cd/home/Bob, or you could do cd. If you're in your home directory, for example, you could do cd /Bob to go up one level and then to Bob's home directory. And if you've probably noticed this when you're looking at the file system and using the ls command, that every directory has 2 directories in it represented by dots. So dot represents the current directory. That's the directory you're in. And then the 2 dots represents the parent directory of your current working directory. And I think you're all familiar with the ls command to show files and directories in your current working directory, or to, if you give it a path argument, to look at files and directories in whichever directory path you give it. And ls, of course, stands for list. And then it has some common options, some of which I'm sure you know about, but some of them you may not. So -A displays all files, including the hidden files. So if you use ls by itself without an argument, any files in the directory that start with a dot are hidden. They're not shown by default by the ls command, unless you give it the -A flag. Then there's the -L flag for a long display, and that displays the file names And then a bunch of additional information like the permissions on the file, the owner, the group ownership, its last modified date, things like that. If you use -H, that shows files in human readable format, or file sizes. So normally it's, you just get this number string with the number of bytes in the file. But if you use the -H, it puts that into human format. So instead of, uh, a long string, it'll say things like 1G for 1 gigabyte or 5.9 M for 5.9 megabytes. The -R flag will give you a recursive listing, so it'll list everything in the current directory and then in every subdirectory under that, and just keeping going down the tree until it runs out. The -S option will sort all the files in the listing based on their file size. The -T option will sort them based on their modification time, and then both of those will also work with the -R option to do the reverse sort. So if you do, say, sort based on file size, it'll sort from the smallest to the largest by default, but if you do the -R, then it'll reverse that and sort from the largest to the smallest. And then the -D option tells it to not display directory contents. So if you're in your home directory and there's a subdirectory, called desktop, and you wanted to look at that directory to see its permissions or whatever, but you didn't want to see the files in it, then you would use the -D option to not show the files under it, just display the directory itself. And then there's another one, a --color, which displays all the listings in color, which is kind of nice. It color codes the file types and all of that. It can make it a little easier to read and spot things. So we'll take a quick look at some of those options to the ls command. So I'm in my home directory, so if I just do ls, you see I get a list of the files and directories there, but none of the hidden directories, nothing with a dot at the beginning of the name is showing up. So that's what the -A option gives you. So now you see all of the directories and files that start with a dot, and these are still just the normal short listing. It's just listing the names of the files and directories. So now if I go one step further and do -AL for all files and a long listing, now it lists the same list of file names, even the hidden ones, but now you see more information like the permissions on the file. So the type of file is the first character, and then permissions on the file, the number of hard links to the file, the owner of the file, the group owner, and then its size is the next column, and then its modified date, and then the name of the file. So now if I go another step further and say add the H option to do human readable sizes, you can see that these are not very big files in my home directory here. 4K, 5K. Now let's add the S option to sort those by size. So now you see that it's sorted by size in descending order. And I think before I said it sorts them ascending by default, but actually I had that backwards. It sorts in descending order by default, but if I add the R onto that now, it'll sort it in ascending order. It reverses the sort on that. And then of course I can use the T to sort by time instead of size. And again, that's going to sort in descending order. So the newest at the top and the oldest at the bottom. And then if I add the R to reverse that, of course, now we get the newest at the bottom and the oldest at the top. And then another command I'm sure you're familiar with, and I know most of you are, is the CP command, or copy. And that's as you'd expect, a pretty simple command. Use CP and then the source file and the destination file. And you can use the destination file can actually be just a directory instead of the full path and file name. So if you use a source file in a directory, it'll copy your source file into the destination directory. Some of the common options that you can use with that are things like the -V to show progress as it's copying, -I to prompt before overwriting files. So if you're copying a file into a directory and a file with that name already exists, without the -I command, -I option, it will just copy the file in there and overwrite the other file. But you can use the -I to prompt you and let you know that there's a file in there with the same name, and it'll ask you if you want to overwrite it or not. Or you could just use the -N option, which won't prompt you but won't overwrite any files when it's copying. And then there's -R to copy recursively, so you can copy a directory and everything under it recursively, which is can be very handy. But then kind of a step above that is the -A option for an archived copy, which does a recursive copy, but it preserves the links and things like file permissions and all of that. So you can, make a copy of a directory and completely archive it, basically, with all of its file permissions and structure and links intact. So kind of an adjunct to the copy command, and another one you're familiar with is MV for move, which moves files. It's also a way to rename files. So if you have a file in your home directory called file1.txt and you didn't want to name it that, you wanted to name it memo.txt, you would use the move command to change its name. You're basically moving it to a new file name in the same directory. And then, of course, sooner or later you're going to need to remove files, and that's accomplished with the rm command, which is short for remove. And that does, it's the delete command essentially. It removes files and directories. On a Unix system, on Unix file systems, and on Linux, file deletion is a permanent thing. There's no undelete option, and on an OS X machine, when you're working in the interface and there's in the Finder and there's a trash can and you drag files into the trash can, you can recover them by dragging them back out of the trash. But that's kind of a symbolic. It's actually a move kind of thing. It's not actually deleting the file until you empty the trash. And once you do empty the trash, it's gone. There's really no undelete. There are some utilities you can find that can potentially recover some data and maybe even whole files and put them back together, but there's really no guarantee of that, as there's no real way to undelete commands effectively. So with the rm command, there are a couple of common options you'll want to know about. There's the -I, similar to the copy. The -I is interactive, so it prompts you before it removes files. So you give it a list of files and it'll prompt you before them to make sure you actually wanted to remove them, which can be handy if you're using a glob to delete a bunch of files without naming them all individually. Sometimes you may catch some files in there that you didn't intend to delete, and having it prompt you for them all can save your bacon sometimes. And then there's the -R flag for removing recursively. So that'll, if you give it a list of files in a directory, or you tell it, files under a directory, it'll recursively go down and remove all the files. And not listed on here, but along with that, most of the time you're going to want the -F command to go along with R for recursive, and that'll forcibly remove everything under a directory. So that's the quickest and fastest way to delete a directory and everything under it. Although that should be used with great care, especially if you're using wildcards or globs to delete files with rm-rf, because that's the quickest way also to lose data. It can be very, very dangerous if you use it in the wrong place, because you can delete a whole bunch of stuff really quickly that you probably didn't intend to, or you may not have intended to. So use that with great care. And then to go along with that, if you're just removing a directory and the directory is empty, you don't really use rm for that. You use the If you just use rm and give it a directory, it'll tell you that, that what you're trying to delete was a directory. And so you use the rmdir, which remove directory, to remove an empty directory. So there's, a bunch of different ways that you can create files on the file system. You can use an editor to create a new file. There are several different kinds of programs that can create files depending on what you're trying to do. Image editors and text editors and sound recording and all of that all create files. If you just want to create a quick empty file to test something or something like that, there's the touch command. So if you use the touch command and give it a file name for a file that doesn't exist, it'll create the file just as a 0-byte empty file. If you give the touch command the name of a file that does exist, it'll update its modification time on that existing file. And then to create a directory, it's the mkdir command, which is short for make directory, and that'll create a new directory with the name you give it. And there's also a -p flag for path. So if you use mk or makedir with a -p flag, you can actually give it kind of a recursive path of directories. So if you're sitting in your home directory and you want to create 3 levels of directory, like temp/foo/bar under your home directory, you can give makedir the -p command, that -p option, and that path structure, and it'll create all of those directories going down in that path. So I'm going to give you a little look at how those commands work, just to give you an idea of how that is, how touch handles files and changes modification times, and how the makedir command works. So let's look at what's in my home directory here. So I'm going to go to the CS41 directory, and there's nothing in it right now. So if I use the touch command and I touch test.file, that doesn't exist now, but when I use the touch command, and now if I look at it, you can see it created test.file right now, and it's a 0-byte file. So say if I go up a directory, back to my home directory, and I'm looking at stuff here, and let's take a look at this examples.desktop file. You can see its modification time is August 22nd. But if I use the touch command on that, and then that changed the modification time to just now. And all touch does is either create a new empty file or change the modification time, which can be a lot handier than it sounds. You may find some uses for that as you're working on files. You can use it as an argument to the find command, so you could touch a file and then find everything older or newer or whatever, because you can actually feed touch a date and time, and it'll touch the file and change the file's modification to the date and time that you give it. So I'm going to go back to the CS41 directory. Let's remove that empty file. So the makedir command, so if I make a test directory, so now you can see I've got a test directory under my CS41 directory, so I'm going to get rid of that. So if I try rm, it tells me that it cannot remove test because it's a directory, so you have to use rmdir. So now the test directory is gone. So if I wanted to create, a path of directories, and I didn't want to do it one at a time, I could do makedir -p test 1, 2, 3 like that. So you can see there's the test directory. So if I use ls-al and then the r for recursive, and give it the test as an argument, you can see that it created test, and then test 1, test 1, 2, and test 1, 2, 3. And I mentioned that when you're looking at the output of ls with the -l option for the long output, you can see the file permissions for the files in the listing. So permissions apply to 3 basic tiers. There's the owning user, the owning group, and then everyone else on the system. And you remember in the output, the first the first name listed is the owner, and then the second name is the group. Usually in your home directory, you'll see that those are going to be the same, because when Linux creates users by default, it creates a new group with the same name as the username. So you'll see that a lot. So here's an example of the ls output for a file. And the permissions are represented by 9 characters. Those are actually three groups of 3 characters, and they represent the read permission, write permission, and execute permission. And execute permission is, of course, for commands and scripts and that, to allow you to actually run them as a command. And that's for regular files. It also applies to directories, and the execute permission gives you permission to change into that directory to make it your working directory, or to just get a list of the files in that directory without specifying a single name. If you can read the directory and you know a file name in it, you can look at that file, but you can't just look at everything in the directory without the execute permissions. So in this example here, I've highlighted the first 3 of the permissions characters in the output, the RW dash, and that means that the file is readable and writable, but not executable to the user that owns the file. And then the next set of 3, in this case they're also RW and dash, and that indicates that the file is readable and writable but not executable by the group that owns the file. In this case, the group is also Disco. And finally, the last 3 characters in the permission string, in this case, are just R dash and dash, and that means that the file is readable but not writable or executable by just anyone else on the system. And changing of those permissions is accomplished with a command called chmod, and that's is the shortening of change mode, because you're changing the permissions mode on the file. And you can use 2 different methods for changing the permissions on a file. You can use a symbolic representation of the permissions, or you can use a numeric representation of the permissions. So in a symbolic version of that command, so for the example here, chmod O plus X. So in this case, with the symbolic permissions, there are 4 characters to specify which user group or person you're changing permissions for. So there's A, which changes it for all of the 3 classes of permissions there: user, group, and other. And then there's U for changing the permissions for just the user. There's G for changing permissions for just the group, or O for changing the permissions for other users on the system. And then there's a numeric way of changing the permissions, and when you change it using the numeric method, you're kind of using an octal mask, essentially, for what the permissions are. And with the symbolic method, you can specify changing the permissions for just one of the sets of those 3 permissions characters. But with the numeric argument, you have to give it the permissions for all 3. And basically, what you're doing is you're adding up the numeric representation of the permissions you want to give, and then putting them as the argument. So the first number in the argument is the permissions for the user that owns the file. The second number is for the group that owns the file, and the third number is for the for everyone else on the system. And the numeric permissions are 1 represents execute permissions, 2 represents write permissions, 4 represents read permissions. So if you add those all together, you get 7, and that gives you execute, write, and read permissions. So in this case, 7 is all permissions, read, write, and execute. 5 is 4 plus 1, so that's execute plus read, so that gives you read and execute permissions. If you were giving just, say just read permissions to a file, that would be 4. So a lot of times you'll also see a permission set as 644, and that's read and write for the user that owns the file, and then read only for the group and other users on the system. So there's a bunch more information on this stuff, and a lot more good information on this in the reading for this week. That's Chapter 4, it's the File System chapter of the Practical Guide to Linux Commands, Editors, and Shell Programming on the Safari Books site. And then, of course, we have the quiz for week 5 and another assignment with some examples of some of these things we've talked about for this week. And as usual, both of those are due next Monday at 12:01 a.m. So have a great week, everybody, and I will talk to you next week.